Hi everyone! Today we will solve this interesting equation. 3 to the power of n minus 2 to the power of n is equal to 65. Now, in order to solve this equation, we need to apply two properties of powers. The first property of powers we will apply is the following. A to the power of 1 is equal to A. That means a to the power of 2 over 2 is equal to a, because 2 over 2 is 1. And the second property is the following. A to the power of b to the power of c is equal to the product of the power, so a to the power of b times c. In our case, we have a to the power of b over to the power of 2 over 2, and we can write it as a to the power of b over 2 to the power of 2. So basically we divide b by 2, and this is the 2 we divide b. So let's apply those two properties to our equation. Now we have 3 to the power of n to the power of 2 over 2 minus 2 to the power of n to the power of 2 over 2. That's equal to 65. And now we will divide n by 2, n by 2. So 3 to the power of n divided by 2 to the power of 2 minus 2 to the power of n divided by 2 to the power of 2. That's equal to 65. Now, let's x equal to 3 to the power of n over 2 and y equal 2 to the power of n over 2. So we can write our equation as x squared minus y squared equals to 65. Okay, now we will apply another property. The property is called difference of two perfect squares. A squared minus b squared can be written as a plus b times a minus b. So we can write this as x plus y times x minus y to the power of, and now we decompose 65 in its prime numbers. So I will write it here. 65 can be written, 65 can be divided by 5, and it's 13, the result. And then we divide 13 by 13, and that's 1. So 65 can be written as 13 times 5. Now, as you can understand, x plus y is equal to 13 and x minus y is equal to 5. This is the first case. X plus y is equal to 13 and x minus y is equal to 5. But we have a second case as well. X plus 5 could be 5. And x minus y could be 13. Okay? So we must study those two systems of equations. Now, if you look at the equations, you see that we have two unknowns and we know the sum and the difference of those two unknowns. Now, there's a property that you should know. Anytime you have the sum and the difference of two unknown numbers, you can find those two numbers applying this formula. In our case, a plus b is equal to s, sum. A minus b is equal to d, difference. So a is equal to, we can sum s plus d divided by 2, and then we get a, and we can subtract s minus d divided by 2, and then we get b. So if we do it here, we know that x, we'll find that x is equal to the sum 13 plus the difference 5 divided by 2, and that's 13 plus 5 is 18 divided by 2, it's 18 divided by 2, 9. Instead, y is equal to 13, the sum of those two numbers, minus the difference 5 divided by 2. That means 13 minus 5 is 8, divided by 2 is 4. That's great. But we can do it to the second system of equations, and then x is equal to the sum 5 plus the difference 13 divided by 2, and that's 8, and that's 9 as before. Instead, y is the sum 5 minus 13 divided by 2. That's 5 minus 13 is negative 8. Negative 8 divided by 2 is negative 4. Now we have a negative number. Now we can now we know that x is equal to, we said 3 to the power of n. X is equal to 3 to the power of n over 2, because we said let x and y. Okay, so we can write 3 to the power of n over 2 is equal to 9. 9 can be written as 3 to the power of 2. Now, in this case, we have two powers that have the same base and they are equal. So, that means they must have the same exponents. So, n over 2 is equal to 2. So, this exponent must be equal to this exponent. That means n is equal to 4. And this is the solution we were looking for. N is equal to 4. We can do the same with the y, and we will find the same value. I will show you. Y is 2 to the power of n over 2, and that's equal to 4. That means 2 to the power of n over 2 is equal to 2 to the power of 2. And again, these two powers must be the same, so n over 2 must be equal to 2. That means n is equal to 4, and we found the same value. So n equal to 4 is one solution. Let's see what happened here. In our case, we have a minus 4. We said that y is equal to 2 to the power of n over 2. In our case, is equal to minus 4. So, as you know, there is no value of n that gives me 2 to the power of n over 2 gives me a negative number. Given 2 is the base is a positive number, so you can put here any exponents and you will never get -4. In fact, if you look at the function of the exponents when the base is greater than 1, this is the function. This one, this is the exponents, let's say n. This is a to the power of n over 2. And you know that and -4 is here, -4. There is no n that will give me a negative number. So there is no solution. In this case, there is no solution. So n equal to 4 is the unique solution we found. Let's check if this is true, if it works. So 3, so we found n equal to 4. So let's see if it works. 3 to the power 4 minus 2 to the power 4 is equal to 3 to the power 4 is 3 to the power 2 is 9, 81. Yes, 9, 27, 81. So it's 81 minus 2 to the power 4 is 16. And 81 minus 16 is equal to 65. So this is the value we were looking for, and this is the solution. N equal to 4. I hope you enjoyed the video. If you did, just subscribe to the channel. Thanks, bye!